Alright, so now we're going to write some code to perform logistic regression. If you want to just look at this code without coding along, you can find it at github.com/lazy programmer/machine_learning_examples and look for the file logistic1.py. Alright, so the first thing I want to do is we're going to need some data in order to do logistic regression on. So I'm just going to create a 100 by 2 normally distributed data matrix. Now we know we're going to have to add a bias term, so we could do something like create a two-dimensional weight vector, do the dot product between x and the weights, and then add the bias separately. But usually we just add a column of ones to the original data and include the bias term in the weights w. And that's the approach we're going to take here. So that was sort of a funny way of creating a vector of ones, but the reason is an array in NumPy is only one-dimensional, and we need it to be two-dimensional in order to have n rows in one column. So now I'm going to concatenate this vector of ones to my original data set to get another vector I'm going to call xb. Alright, I'm going to randomly initialize a weight vector. Now it has to be of length t plus 1. Also keep in mind it doesn't really matter what the values are right now, since we don't have any labels. We just want to be able to calculate the sigmoid. So the first thing we want to do is calculate the dot product between each row of x and w. So you're probably thinking we can do this in a for loop, but it's actually much more efficient to use NumPy's built-in matrix multiplication. If you're used to MATLAB, the asterisk or star means matrix multiplication, but in NumPy it means element by element multiplication. I've mentioned this before in my other courses as well. When you want to do matrix multiplication in NumPy, you actually use the function dot. So that's what I'm going to do. So here's another strange thing, is we usually write w transpose x as the inner product, but since w and x are usually d by 1 column vectors, here what we have is an n by d, where each x is a 1 by d row vector. We're going to do it backwards. So now this gives us an n by 1 vector, which you can verify by printing the shape. Now what we have to do is apply the sigmoid. So I'm going to write a function that performs the sigmoid operation. And the nice thing about NumPy is that they act on vectors as well as scalars. So we only need to run it through the function once. Alright, so I'm going to just copy and paste that into my IPython window. I forgot my equals sign. Let's try that again. Alright, so you can see that our output is n by 1, and our little values are between 0 and 1, as we expected.